Hello, this is FlippedHarber for Algebra 2. In this video we'll be covering section 2.4, writing linear functions. The objectives for the lesson include using the slope-intercept form and point-slope form to write linear functions, and writing linear functions to solve problems. Our topics for the lesson include the slope-intercept form, the point-slope form, parallel and perpendicular lines. Alright, let's start with the slope-intercept form. Given a graph of a straight line, writing the slope-intercept form is pretty easy because we only need to find two things from the graph. The first thing that we need to find is b, that is the y-intercept of the graph. That's where the line goes through the y-axis. Now the b for this graph would be pretty easy to spot because the line goes through the y-axis at 3. So b equals 3. The next thing we need to find from the graph is the slope. Now we're going to need to find 2 points on the line in order to find the slope. Then we'll just do a change in y over change in x calculation. Put everything into the slope-intercept form, which is y equals mx plus b. Now, like I said, our b value is 3. That's nice and easy to read off. Then we need to pick 2 points that we can read fairly easily off the graph. Now basically what you want to do is choose points where it's going through these blue line corners. So I decided to use the point 0, 3, that is the y-intercept, as well as the point 4, 6. Plugging everything in to do a slope calculation, 6 minus 3 over 4 minus 0, we find a slope of 3/4. Now we really want to leave slopes in fractions like this. Don't plug it into a calculator and get 0.75. Leave it as a fraction because we can use that fraction as rise over run. So we plug everything into our slope-intercept form. We get y equals 3/4 x plus 3. Okay, let's move along. The point-slope form of the line is an equation that we use when we know the slope and we know 1 point on the graph. Now this is a good starting point. We generally don't keep equations in the point-slope form. We usually want to take them from the point-slope form and turn them into the slope-intercept form. So obviously we'll go over how to do that as well. When you're plugging into the point-slope form, you are plugging numbers in where you see y1, m, and x1. Leave the y and x alone. Just leave them as y and x. So let's use the point-slope form and write it for the line that has a slope of 2 and goes through the point 1, 2. So we're told a point 1, 2. We're told a slope. So this is a perfect form to use. Now we're plugging our point in for x1 and y1, and we're plugging our slope in for m. So this would be the point-slope form for the line that has a slope of 2 and goes through the point 1, 2. Now let's look at how to change it into slope-intercept form. First thing we'll do is go ahead and distribute the slope in. Multiply the 2 times the x and the 1. And then the last thing we do is just add over the 2 that's on the left side. We get y equals 2x. So now it's in slope-intercept form. We can still read off our slope really easily. Our slope is 2. We already knew that though. But now I can see that my y-intercept is 0. When we don't see a number added or subtracted at the end, then our y-intercept, our b value, is 0. Let's talk about using tables. When they're giving you a table of data, they're giving you a whole bunch of points. Well, that's really handy, but we really need to use 2 of these points to find a slope. All of our forms for our lines rely on knowing what the slope is. Whether it's the slope-intercept or the point-slope, you need to know what the slope is. So pick 2 points, doesn't really matter which 2, plug them in and get a slope. So here, using our point 3, 0 and negative 1, 1, we find out that our slope is negative 1/4. Now you're going to find that exact same slope no matter which 2 points you use from this data. So just go ahead and use the easy points. You probably want to stay away from those decimals. Now, we know our slope. Now we want to be able to come up with the slope-intercept form of a line. Now here's one way to do it. We'll go ahead, plug in our slope, -1/4, and we'll choose a point to plug in for y and x. So I chose the point 3, 0, plug the 0 in for y, plug the 3 in for x, and what that lets us do is solve for b. We find out that b is equal to 3/4, so I can fill it in, and I've got my slope-intercept form. My slope-intercept form is really my default form. If they don't tell me any different, if they just say find the equation for this line, put it in slope-intercept form. That's our default. Well, let's look at this exact same one slightly differently. Since we know the slope and we have a whole bunch of points to use, let's go ahead and look at it with the point slope form. Choosing any point will work for us. Might as well choose one of the nice numbers, so let's use the point -1, 1. So we're going to plug -1 in for x1, we're going to plug 1 in for y1. Now notice inside the parentheses it becomes x plus 1 because it's really x minus a -1. We distribute in the slope, and then we add over the 1, and we get the exact same equation. You really should get the exact same equation. It's the exact same line. The equation should be the same. Alright, let's talk about parallel lines. Now, parallel lines have the same slope. That's how they're parallel. So it works both ways. If we say that two lines are parallel, then we know their slopes are the same. If we know that two slopes are the same, then we know that those two lines are parallel. That one's pretty easy. Perpendicular lines, little more complicated. The relationship is that the slopes are opposite reciprocals. So that means that we need to do two things in order to find perpendicular slopes. We need to change the sign on the slope, and we also need to flip the fraction. So these two lines are perpendicular because one has a slope of 2/3. The red line has a slope that is the negative reciprocal. It's -3/2. And again, this works both ways. If I show you two equations and you see that the slopes are negative reciprocals, you know those lines are perpendicular. If you know the lines are perpendicular, then you can say that their slopes are negative reciprocals. Now notice here on the right side, if you multiply the two perpendicular slopes, they equal -1. That's just another way to show that they're negative reciprocals. Okay, so that's it. You know what your homework is. It's time to get to it. I'll see you in class, and I'll see you online.